I'm going to go over the homework from primes and fundamental theorem of arithmetic homework. So this would have been Wednesday night's homework. When an integer n is divided by 5, the remainder is 3. What is the remainder when 4n is divided by 5? So we're just going to divide this. Again, we have a quiz coming up on Friday, so as we're going through this, recognize this type of question that's going to be on there. So when integer n is divided by 5, the remainder is 3. The smallest number that I can divide by 5 and get 3 is 8. So 5 goes into 8 one time, and the remainder is 3. So my number n is equal to 8. What is the remainder when 4n is divided by 5? So n is equal to 8. 4 times 8 is 32. So I want to know when 5 goes into 32, what's my remainder? 5 goes into 32 6 times. 5 times 6 is 30. When I subtract, I get 2. And so my remainder is 2. So the remainder equals 2. Determine if the following numbers are prime or composite. Use divisibility rules to help. 37 is prime. 87, 8 plus 7 is 15, so we know 3 goes into it, so that's going to be composite. 171, 1 plus 7 plus 1 is 9. 9 goes into it, so it's composite. 193, 1 plus 9 plus 3, that's 13. 3 does not go into it, 9 does not go into it. It's obviously not an even number. No even numbers we know go into it. So we really kind of just have to go to the calculator and divide this thing out. So what's that, 193? 193 divided by, and we can just pick some numbers. We know 3 doesn't work. We know 5 doesn't work. We try 7. That doesn't work. 193 divided by, we know 9 doesn't work, so that's a multiple of 3. 11, that doesn't work. 193 divided by 13. 193 divided by 15 doesn't work. 17. 193. All right, so we're already, so 193 divided by 19, that doesn't work. And notice the numbers we're dividing by have surpassed these numbers. There's a point at which the numbers flip-flop and one is larger than the other. And that's the point at which we're done checking, because no other number, because the other number would have to, like this number, we've already checked all the numbers that are up to 11. And if we divide it by a number, we're not going to be able to get a number that's smaller than 11 because we've checked all the prime numbers lower than that. So we know that this one is a prime number as well. Prime. Find the prime factorization of each composite number. So we're just going to break these numbers down. 48 divides into 6 times 8. Factors of 6, 2 times 3. Factors of 8, 2 times 2 times 2. So that's 2 to the 4th times 3. So prime factorization, 105. We know that 5 goes into it. 5 goes in there twice, 21. And then the 5 comes down, and we got 3 times 7. So this is 3 times 5 times 7. Again, lowest to highest. 180 breaks down to 10 times 18. 10 is 5 times 2. 18 is 9 times 2. 9 breaks down to 3 times 3. Bring down the 2, bring down the 2, bring down the 5. 2 2s, 2 3s, and a 5. 500 is 50 times 10. 50 is 25 times 2. 10 is 5 times 2, 25 is 5 times 5, bring down the 2, bring down the 5, bring down the 2, 2 2s, 3 5s, 2 squared times 5 to the 3rd. And again, you guys have calculators, so you can do this with a calculator if you find it necessary. 360 breaks down to, let's see, 36 times 10. 36 is 6 times 6, 10 is 5 times 2. 6 is 2 times 3, 6 is 2 times 3. We got a 5, we got a 2. 3 2s, 2 to the third, 1 2 3s, 3 squared, and a 5. 663, looks like 3 is going to go into that. 663, 3 goes into 21. Goes into 221. 221. I don't know. Let's see. Let's use calculator. Clear. Here's the neat little trick. I could do 221 divided by x. And I can go to second graph. And I get a table of values. Looks like 13 times 17. 13 times 17. 221 is 13 times 17. I think I should have known that. All right, 13 times 17. This 3 comes down. So this prime factorization is 3 times 13 times 17. And notice I used the calculator to do that. You can use the same. You don't need to do all these in your head. 3675. Whoa, 3675. I'm going to add all these together. 3 plus 6 is 9, plus 7 is 16, plus 5 is 21. So 3 goes into it. 5 obviously goes into it. So I'm going to employ my calculator here. This is 3675. I know the rule of 3 works, and I know the rule of 5 works, so 3 times 5 is 15, so that's going to help me break it down a little bit quicker. So I'm going to slide it over here, and go to my home screen, and then 3675 divided by 15, it's going to be 245. So this is 15 times 245. 5 plus 4 is 9, 10, 11. So it doesn't go, the 3 doesn't go in again. But 5 does. So 245 divided by 5. It's going to be 49. 5 and 49. 15 is 3 times 5. And then 49 is going to be 7 times 7. Bring down my 5, bring down my 5, bring down my 3. And so I have 3 times 5 squared times 7 squared. And notice I use my calculator on that one. As they get larger and larger, I'm going to use my calculator. It just makes sense to use the tools that you're given. 8316. 8316. I know that 5 doesn't go into it, but it was 8, so 11, 12, 18. So a 9 goes into this thing, and it's even, so, and 4 goes into it, so I think I'm going to divide by 36. Let's try it. If it doesn't work, it doesn't work. But it does, because math works 100% of the time. All right, 8316 is 36 times 231. 8316 breaks down to 36 times 231. Let's try 2 plus 6. 3 goes into 231 for sure. So 231 divided by 3. It's going to be 77. 77 times 3, and 36 is 6 times 6. 77 is going to be 7 times 11. The 3 comes down. 6 is 2 times 3. This 6 is 2 times 3. So I have 2 2s, 2 2 squared. And then I got 1, 2, 3 threes, 3 to the third, and then I have a 7 and an 11. And I can always check to see if this is true. I could do 2 times 2 times 3 times 3 times 3 times 7 times 11, and I should get 8316. You can always check my work. Remember, math happens on paper, checking happens in the calculator, so we should always check if we can. All right, use the fundamental theorem of arithmetic to find the smallest positive integer n such that 444 times n is a perfect square. Write the resulting product as a perfect square. All right, so we're going to find n first, and then we have to write the resulting product as a perfect square. So there's 2 parts to this. So I have 444 times something, and I need to break this down for. I think 4 goes into this. That's pretty clear. 4 goes in, 111. 1 plus 1 plus 1 is 3, so 3 obviously goes into this. 3 goes in, let's see, that goes in 37 times, and 4 is 2 times 2. So this breaks down to 2 squared times 3 times 37. So I need this to be a perfect square. I need another 3, because then I'll have 2 3s. And I need another 37. So 3 times 37 is my n. So I'm going to use my calculator to multiply 3 times 37. 3 times 37 is, well, of course it's 111. We knew that. 111. So n equals 111. That is the number that I multiply by to make it a perfect square. Write the resulting product as a perfect square. So 2 squared times 3 squared times 37 squared, right? When I added this 3 and this 37, it becomes that. All those numbers are squared. So that is a perfect square. I'm going to write the final number. I'm going to multiply those numbers out. So we got 2 times 2 times 3 times 3 times 37 times 37. And that's 49,284. 49,284. And that's my perfect square. So we need to find n, where 1575 times n is a perfect square. So I have 1575. If I add the numbers up, 5 plus 5 is 10, plus 7, 17, 18. So 9 goes into it. It ends in a 5, so 5 goes into it. So we know 9 times 5 is 45. So 45 is going to go into this number. I'm just chunking this number because it is so large. But I use the rules of the divisibility rules to know that 45 goes into it. So 1575 divided by 45 is 35. All right, so that's going to be 35. And this breaks down a lot easier. 45 is 9 times 5. 35 is 7 times 5. The 9 breaks down to 3 times 3. The 5 comes down. The 7 comes down. The 5 comes down. And so this is 3 squared times 5 squared times 7. The only number that isn't squared here is 7. So I need to multiply it by another 7. N equals 7. So find the smallest positive integer n such that this is a perfect square. N equals 7. Number 16, use the fundamental theorem of arithmetic to find the smallest positive integer k such that 864k is a perfect cube. So remember, when we're dealing with perfect cubes, we're trying to find factors, the prime factorization, and they have to have an exponent of 3. So we do 864, and we're just breaking it down. 8 plus 6 is 14. So 9 goes into it. And it looks like 4 goes into it. So this should be divisible by 36, since 9 and 4 both go into this. So again, I'm employing my calculator. So I have 864 divided by 36, 24. It's going to be 24. Factors of 36 are 6 times 6, and factors of 24 are 6 times 4. And 6 is 2 times 3, and this 6 is 2 times 3, and this 6 is 2 times 3, and this is 2 times 2. So I have 1, 2, 3, 4, 5 2's. So that's 2 to the third, and then 2 squared. I got 5 total. I'm splitting them up so it's easier to see. You can certainly write them all together. And I have 3 to the third. So this is good. That is a perfect cube. We're good on that. This is a perfect cube. We're good on that. I need this to be a perfect cube. What I need to multiply it by to get a perfect cube is another 2. So n, or k equals a 2. If I multiply this by 2, that's going to be 2 to the third, and that's the number that we need to make this complete. That should be enough for you to do well on this Friday's quiz. So make sure that you watch the notes, and then you complete the homework assignment, and then you prepare with the Canvas assignment for the quiz that's going to be on Friday.